Hi everyone, I hope you're well. Please say hello in the comments, I shall welcome you warmly. We have so much to do today. We're into paper one. No, we're into paper two. So we're looking at algorithms, we're looking at design, we're looking at the pseudocode. And I know this is the area that's given you the most stress out of everything in the exam. So let's try and demystify a part of this today. And if there's nothing new in today's one, then I think there will be something new when we go on to look more at algorithms later on. But we'll be practicing this more anyway between now and the exam. All right, so please say hello in the comments. So, hi Aditya, how you doing? Great to see you. Now, I've not got much in the way of quizzes before we start today because I've got a terrible feeling I won't get through everything otherwise. So, if I can go back and do some more quizzing at the end, I'll do it. But I kind of want to try to get through as much of this as I possibly can in the time that I've got. I think there's a benefit to me doing this. In half an hour because it makes me focus on trying to deliver a lot of content in a short period of time. So I reckon we can get through this in half an hour. Let's just do one question. This one is from last week. And this was to do with some of the definitions we'd looked at. We had decomposition, abstraction, input sanitization, and casting. Can anyone remember what this combination was? Hi, Bogdan. Thanks for coming. Great to see you. And Emad, hey, how's it going? Oh, we've got Aditya who's jumped in straight away with debaf. Do you know, I can't remember, but I think that debaf sounds like about the right combination. Should we see if that's the case? We've got Bogdan who's saying debaf. Well, if you two agree on debaf, I'm not going to argue with that. Let's see where we are. The answer is debaf. You guys are superstars. That was quite easy last week, wasn't it? The abstraction decomposition. So let's move on and think about what we need to do this week. What's it all about? Well, we're now moving on to, I suppose, the 2.1.2, which is the second part of paper 2. And this is about identifying inputs, processes, and outputs for a problem. We'll look at structure diagrams, and we'll look at pseudocode, flowchart, and reference language. Now, of course, we're not going to have time to go through all the reference language today. However, on the specification, once you scroll down through the content, there's a section of, I want to say, 8 pages of pseudocode. Make sure you're doing a little bit of that each night because there is no substitute with just looking through that, looking at the examples so you can recognize and use these in your own pseudocode. And then we'll look at common errors, which is dead easy, and trace tables, which I think is pretty straightforward. It's just a way of sort of checking to make sure that your algorithm actually works. Okay, so without any further ado, let's do the 10-minute teach and jump on with this. It's 32, so we're rushing into this nice and quickly. And Flynn, by the way, debaf, you were absolutely spot on. I just didn't pick you up in time. So debaf, but that was quite easy, wasn't it? Right, so designing, creating, and refining algorithms is what we need to focus on today. Let's start by a definition of what an algorithm is. It's a plan, it's a step-by-step process. And whether you're brushing your teeth, getting dressed in the morning, fixing a car, or baking a cake, you've got this idea that it's step-by-step instructions to solve a problem. And of course, when you write a computer program, it's an algorithm that you're creating. So let's do the easy stuff first of all. We'll look at inputs, processes, and outputs, because those are the 3 fundamentals of any computer system. You input data, the data gets processed, and there's an output, there's a result from it. And that's basically it, okay? So those are the 3 sort of stages of any computing that you do. There's an input, there's a process, and there's an output at the end of it. I'm going to whiz through these early slides because I know that you know all of this. So here's an example, and it's the heating example that we tend to use to death because it's the one that makes the most sense. So the input's going to be, so this is a thermostat, and this will be measuring the current temperature in your room, all right? And that's the input. So the current temperature is going in, and then you will set the temperature on the right-hand side there with the up and down button as to what you want the temperature to be. And then depending upon the difference between the temperature that you set and the current room temperature, the output will be that it turns the heating on. We're going to look at the 2 different flavors or types of loop. I use the word flavor, the 2 types of loop, and we'll also look at selection as well. And we'll look at use case as well. Use case you don't actually need to use, but recognize you can use it. You won't get any extra credit for using it, but recognizing the case is really important. Switch case is really important. All right, so that's our first steps: input, process, output. Now we come on to our flowchart. So what isn't very helpful about this diagram is that the symbols are actually incorrect, but that would bother me. But let's just look at the principle, okay? You've got boxes that are processes, you've got a terminator at the start and end, and then you've got some decisions as well. And the decision is that triangle. Did they guess it? No. Or did they guess it? Yes. Now, what you can't have when you create a flowchart are orphaned boxes, as they're called, that are boxes sat on their own. The start box is on its own, and the end box at the bottom will be on its own. But everything else has to join into the diagram, hence a flowchart. Also, when you build these, the idea is the flowchart flows downwards. It will need to go to the side sometimes, but it should flow from top to bottom. That's the idea, okay, that it sort of flows through the system. So there's a fairly easy one. Draw a picture. Did they guess it? No. Point repeatedly to the same picture and say it more loudly and more angrily, and then they still won't get it. So that's fundamentally Pictionary in a flowchart for you. Okay, so let's move on to the more specific part about this. If you want to get full marks for this flowchart question, you need to make sure that you know what these symbols mean. Everything has to be joined together by a line, and you need to draw an arrow on the line to show the flow of information, the flow of data, the flow of processes, okay? Because this is about processes. When you're inputting or outputting something, you use that parallelogram, which I said very carefully because it's a word that I really struggle with. The process, as we said, is the diamond. The terminal or the terminator, that's the start and stop at the beginning. You've got sub-programs on the left-hand side, and you've got processes, which is the rectangle. So you're wondering, what's the difference between an input, an output, and a process? Well, basically, if it's not an input or an output and it's something happening, it's a process. It's a fairly easy way of putting it. So you're limited to those. You're unlikely to have to use a sub-program when you're creating a flowchart at GCSE, but they may well include that particular symbol just to make sure that you know what it means, okay? So it's a process, but it's got those two vertical lines sort of towards the end of the boxes. So make sure you're happy with what each of these different symbols represents, okay? Oval shape, start or stop, the process, the rectangle, the decision, and the data, and that's for input or output, all right? Good. So let's move on to the next one. Now, with the flowcharts, students often think it's easier to answer a question with a flowchart. And of course, in section A of paper 2, you've got the freedom to use whichever means you wish to demonstrate an algorithm. You can use pseudocode, you can use Python, or you can use a flowchart. But just beware that sometimes, if it's a complex algorithm, it can actually be quite difficult to show it in a flowchart. I think flowcharts are easier to read, but sometimes they're actually quite difficult to write because you've got to keep adding boxes left, right, and centre. And sometimes writing it out in words first is actually a big help. Anyway, let's look at pseudocode now. We know that pseudocode is another method of expressing an algorithm, and it's lines of instructions which are close to English, and it's got these commands that you find in programming, selection and iteration, and the various commands we'll come on to shortly. An OCR reference language, which I'll now sort of mention for the second time, at the specification after the content. That's where you'll find the reference language. Get your heads into it. Make sure that you are au fait with everything in there. Now, what's the ditty said to me? A line is not an arrow. OCRB, cutting marks for students who draw lines instead of arrows. A line is not an arrow. OCRB, cutting marks for students who draw lines instead of arrows. I don't know. Cutting lines. Interesting, Aditya. Chat to me about that, because I'm not entirely sure what you mean, but I'll be interested to hear what you mean by that. I kind of get it, but I'm not quite sure. Anyway, pseudocode. So there's no strict notation for pseudocode, and in fact, it's in the name really. It's the specification calls an arrow a line. Oh, does it? Okay. The specification calls an arrow line. So are you saying there shouldn't be arrowheads on the vertical lines? Is that what you're saying? That's what I'm reading. come back and let me know. So there's no strict notation for pseudocode, but these are the ones that you need to recognize. We've got an input, we've talked about before, we've got an output. Now we get into the meat of this, right? The repeat until, the while, the for, and the if then else. Those 1, 2, 3, 4 are the only 4 structures that you really need to know, the constructs, okay? So let's talk a little bit about those. Repeat until. Repeat until is an iteration, it's a loop, except the condition is at the end. The while is a loop, the while loop, with the condition at the beginning. And what we'll need to explore next time or in class is when you would use one rather than the other. But that's the fundamental difference, okay? The condition being at the beginning or the condition being at the end, right? But they still both do much the same thing. Then we've got the if then else, which is the selection when a choice is being made. Okay, so really we've got 2 flavors of iteration, and then we've got the if then else, the selection. The specification calls an arrow a line. Okay. Hi Swiftblade, how you doing? Thanks for coming. So Swiftblade, you're here in time to see, I think, the most important thing we're doing today, which is really just recognizing that you only have a very small handful of different bits of code that you need to learn. The repeat until, the while, the for, and the if then else. And we know that the for is a count controlled loop. So for example, I always use the example of a Formula 1 race, which is 50 laps long, and it iterates from 1 to 50, and after 50 it finishes, the loop stops. The condition controlled loop is more like a heating system, which will turn on and then turn off depending upon the condition. It'll keep the heater on while the temperature is below a certain temperature, and then when it goes above it, it'll turn it off. So you've got those 2 different ideas, okay? And the last thing there is just this idea that when you're writing instructions, when you're putting these constructs onto paper, the instructions that occur inside a selection or iteration are usually indented, which means that they are moved into the page a little bit. Okay, so that's the idea of indentation, and they do sometimes give marks for that. They do like it to look right. But again, that's when we're looking at section B of paper 2. Section B of paper 2 is the part that if everything else is good in your paper, that's the bit that's going to make the difference between grades 7, 8, and 9, because that's when things get really sticky. I will go through those with you, okay? Bearing in mind that because I've only got 18 minutes left, so we'll go through those in probably in class Aditya. But I just wanted to go through the different loops and the different constructs you've got available to you, okay? All right, so let's have a look at this one. Now, bearing in mind, you can use any format that you like for writing pseudocode. You can use exam reference language pseudocode, or you can use Python. But the sort of thing they're expecting to see is this. So let's look at input output. So for example, input message equals hello world. They always do hello world with Python, don't they? And then output message. So it's that simple. And I think if you look at the first page or 2 of the exam reference language, they do an example around passwords, and it seems to be 50% of the time that they ask a question based on that, or they ask you to create something which will involve the user entering some data, and that data will get saved as a variable. Okay. So, and by the way, practicing these, doing one of these every day is going to be the surefire way of just feeling a bit more confident with them when they come to when you come to the exam. All right, so that's your input and output. So let's have a look at this one here. We've got the if then else. So on the left you've got the sort of the theory, if you like, and then on the right hand side you've got what the code should look like when you write it down. So if condition whatever, then do something, else if do something else if do something else. So this is the selection, right? This is the example of if you're trying to give someone over 70 marks a grade 9 over 60 marks a grade 8 and so on. Okay, so you'd use it for this sort of thing where you've got several conditions, and then so you've got else if, then else, else, else. Okay, so this might look like if entry is the same as A, because don't forget double equals means is the same as, rather than using an equals on its own, which is to declare, to assign a value to a variable. Then print you've selected A, else if entry equals B, then print you've selected B, else print unrecognized selection, all right? So they will get you to use this in the exam, and they will set up some kind of scenario where you've got to produce this in the exam. So make sure that you're happy with the indentation, make sure that you're happy with the vocabulary that you need to use. I mean, it's pretty straightforward really, isn't it? But they're going to check to make sure that you do understand this, and this will be across paper 2 that they'll do that. Okay, so that's selection. This is the second flavour of selection, which you can use to answer a question if you like, but at the very least you need to be able to recognise this. So this is the switch case, switch entry. And again, case A, print you've selected A. Case B, print you've selected B. But the default is the catch-all at the end is going to be print unrecognised selection. So as long as you understand what that's doing, and I mean, you'd use one rather than the other depending upon the amount of data that you're trying to that you're trying to sort, if you like, that you're trying to work with. But fundamentally, for the purpose of GCSE, all you need to worry about is to make sure you understand that this is just another flavour of selection. You don't have to use it. You can if you like, but recognising it is something which which you'll need to do. I have a suspicion that this is going to weave its way into the exam, because that has remained, and they haven't done a question on this for the last 2 years. Not that that means there'll be one, but I think they might. So just bear that in mind, that you need to recognise this at the very least, okay? So that is the selection part. Hello, Harsh Plays, how you doing? I hope all is well. That's a very neon icon you've got there. I like that, very nice. Thanks for coming. And don't forget, you can catch up with this. I'll put it on what units of measurement? I think that we are looking at, is that the byte kilobyte, that bit, where you've got to know bits, bytes and all that sort of stuff. Have a look at the spec. I can't remember offhand, which is probably quite a good thing for my sanity that I can't remember the entire specification offhand. I've got a couple inside my head. All right, so let's look at pseudocode iteration and look at the while loop. So while condition X, then do something, end while, or for condition, then do something, end for. So you've got two examples there, okay? Input entry. While entry is not the same as A's, that's the exclamation mark followed by the equals, then print, please enter A, end while. So that's setting up that condition. Then we've got beneath that, for I, I'm aware I've only got 12 minutes left, for I equals 0 to 5, then print enter A. So of course you can see that for I equals 0 to 5, that is a count controlled loop, okay? How many times is that loop going to repeat, my little geniuses, my little genii? How many times is that going to repeat? And my second question is, it doesn't matter, but what does I actually stand for? Why do they always use I? I'm sure I've told you. So I equals 0 to 5, how many times does that repeat? I can see that Bogdan has absolutely nailed it. And don't forget, you know, when people always ask me, why do they put -1 at the end of things? It's because things start at 0. Okay, well done. Well done, you guys. You're all superstars. Well done, Emad. Well done, Aditya, and well done, Bogdan. Absolutely spot on, okay? That is exactly it. The second time, but I won't hold it against you. All right, so that is the one we're looking at there. Now, I have got a pack of 50 or 60 of these questions that you can just do one a day, just to make sure that you're familiar with them, all right? So it's really just a question of practicing them, because looking at it in this way, dry like this, just looking at the theory, it's okay, but it's when you see them in practice that finally you go, okay, I feel happy to use those. All right, I've got 10 minutes left. Let's look at trace tables. There's some good questions at the end of this. So trace tables are a way of keeping track of an algorithm to make sure the thing actually does what it's supposed to do, okay? So when you've got nested structures and they become more complicated, so a nested structure is a structure inside a structure, and they might make you do that over the course of the exam. And of course, if they do a nested structure, that's going to be, if you want the 8 or the 9, you need to nail that nested structure when you've got to put one statement inside another, okay? Nested if statements, for example. So the algorithm below contains a simple for loop for I equals 1 to 4, output I times 2, I star 2, endfor. And so you can see there, it's got the iteration on the left, 1, 2, 3, 4, and it's showing what the output will be. So the first time it will be 2, then 4, then 6, then 8. Okay, so that's what it's doing. All right, happy? That is trace tables. What have we got next? All right, so common errors. Let's whiz through this. Are trace tables used for identifying logic? Yes, you can use them for that as well. Yeah, you absolutely can use them for doing that. Okay. All right. So, I think I've got an extra one here. I don't want to do that. I'm back. I have lost my camera. Just bear with me 2 seconds, because I know you'll struggle to be without my face. It must be very, very hard. So just bear with me 2 seconds while I find the battery. So this is logic errors and syntax errors, guys. 2 types of errors. Syntax errors, the easy way of remembering syntax errors is that basically they are... Am I back in the room? I'm back in the room. Let's get that sorted out. There we go. Right, syntax errors, they're basically spelling mistakes. And logic errors are where the code... So in a syntax error, it will use some computing grammar, which makes no sense, but you know what I mean. It'll be a sort of misspelling in a code, whereas a logic error is that the code makes sense. It just doesn't work. So, for example, using a greater than rather than a less than, so the code will run. It will give you the wrong results. So you've got 2 different types of errors there: syntax and logic, and they often give you a piece of code, and they'll say on which line is the error, what's the error. All right. So syntax error in spelling, logic error, errors in the logic of the code, or rather than and, which is a better example, but greater than, less than, so, or any combination of those sorts of things. So those are the sorts of things they do for those errors. All right, quiz time. We have made it, which is good. Right, I wanted to get to this because I know you'll quite enjoy this. What about this one? Look at the pseudocode algorithm. Identify the output if the user enters the value 6 and 4. So what do we think? I will be genuinely interested to see who gets here first. Ooh, a ditch is coming with 6. And do we think this is the final answer, guys? I'll give you 20 seconds to just come up with that while Aditya. Let me just do. There we go. 20 seconds. Emad 6. Bogdan 6. Flynn is 6. Are we quite sure about this, guys? We totally sure 6 is the answer, are we? Yeah, everyone's saying 6. Okay. I will take that as your final answer then. The answer is 6. So well done. I was trying to spook you. Okay, what about this one? This is harder. Well, it's not harder, but there's more work to getting to it. Look at the pseudocode algorithm below. Identify the 4th value, the computable output, the 4th value. What do we think? What's the 4th value? This time I think I might get a chance to actually have a slurp of my drink. I'll put 20 seconds on the clock. Here we go. What do we think? 4th value. I'll start the clock as well. There we are. Ooh. Well, I'm feeling quite smug. This is clearly making you think. B. An interesting concept, but I'm after a number rather than a letter. But I admired the speed at which you came to that conclusion, but I'm after a number. Do we have any idea? I have a mute mic button, so you don't need to hear me slurping coffee. How good's that? Any ideas? Well, I have to say it's all gone remarkably quiet over here. Perhaps if I put another 20 seconds on the clock. Bogdan thinks it's 4. Interesting answer. Bogdan thinks it's 4. So, any other answers? Not saying it's right or it's wrong, Bogdan. Necessarily. Bogdan says it's 4. I will put 20 more seconds on the clock to give anyone else a chance who wants to answer this. And let's see how you've done. 5 minutes left. Okay, well, we'll go with Bogdan's, shall we? So Bogdan's final answer is 4. We've got either B or 4. Shall we see what it is? The answer is 2. So what I recommend is that you spend a bit of time, and the answer is 2, by the way. So I recommend you spend a bit of time looking at why that was 2. That was a bit of a difficult one, that one. But given you all got it wrong, that's good. That means that that means you can go back and check that one afterwards. All right, let's try this one. Look at the pseudocode algorithm below, which contains an error. This is easy. I want to know where the error is and which line it's on. This is a typical GCSE question. I think this one's quite easy. What do we think? What do we think about this? This should be very straightforward. It's the print being first which completely threw me. Okay, Flynn, you are absolutely spot on. Oh, I haven't given out any dings today. There we go. There's a ding. Oh, and I'll give Bogdan something. And I need to give who was it? Swift Lady said B. Okay, Prent. Yes, Prent it is. Okay, syntax error, line 7. Well spotted. Well done, Bogdan. That's the sort of thing that they ask. Is they'll say which line is it on. They've misspelled print a few times, okay, and it is a syntax error. It's a spelling mistake, okay. Right, good. So that's that one sorted out. The mistakes are straightforward, and I think they're conceptually quite easy to spot. It's a syntax error, and it's on line 7. It should be print rather than print. Okay, I reckon you'll get this one quite quickly. Question 4. Look at the flowchart. What would the output be if the input was 38? What do we think? Oh, crumbs. Bogdan's come back very quickly there. Look at that. Within limit. Bogdan, you are on fire. Not literally, I hope, but that's very good. Aditya says within limit. Well, let's see if you two are spot on, shall we? Within limit. And the answer is dun dun dun. Within limit. Yay. That is outstanding. Okay, this one here, look at the flowchart. Some shapes are missing. Hang on, we had loads getting it right here. We had Flynn who got it right, and we had, well done, dear boy, and Emad, well done, dear chap. Within limit. Right, question 5. Look at the flowchart. Some shapes are missing. How many of the shapes should be input-output parallelogram boxes? It's a word that I really struggle with, parallelogram. How many of the shapes should be input-output parallelogram boxes? So, Aditya has come in with 4. Any more takers on that? Or shall we take Aditya at his word? He's been pretty solid today. Some good lines questions we'll need to get to the bottom of. Emma's got a 4. Okay, let's have a look. I've got a suspicion that you guys are absolutely spot on. The answer is 4. Oh dear, Bogdan came in with that one too late. I don't know. You can't get the staff, can you? Okay, so let's go on to the next one. Where are we? We are not very far away now. Okay, I think I've got one more of these, if I remember correctly. Okay, here we go. Last one. And it's 59. This is good timing. In a flowchart, what shape would you use around the does the password contain a number? Which you might struggle to put inside that shape, but anyway, that's neither here nor there. So in a flowchart, which shape you would use? Oh, I did you straight in with A. And you, dear boy, are absolutely spot on. Let's give you a little ding. The answer, I spotted the mistake I made earlier. Okay, I take it back. Hey, listen, well, I've got the answers here, Bogdan. It's dead easy, to be fair. Everyone can be a smarty pants when they're when they're pressing the buttons. You've got Emad who's got an A as well. So guys, you're all ding, ding, ding. You are spot on. Okay. So listen, we've covered a ludicrous amount of ground in a very short period of time. And I know that probably most of you were aware of most of those. I think the next step for a lot of you is just to get practicing with them, okay? To make sure that you actually sort of do some of these algorithms and that you spend a bit of time figuring out how you will produce them in the exam. So, and that's really just for that section B of paper 2. So next week, we're going to look at the standard search algorithms. So we've got 5 to look at in total. We've got 2 searches and 3 sorts. And the job really will be to make sure that you can explain how they work, that you can recognize the advantages of one over another, why you would use one for sorted lists and one for unsorted lists, one for longer lists, one for shorter lists, but also that if they give you a list of unsorted items, you can show the steps using those items to actually do the sort of the search. Okay, it's 1901. Let's have a look. Are there coding questions on the Hazel Wikipedia website? No, there aren't, Bogdan, but what I will do, and I will do it probably tomorrow, is I have got a pack of an algorithm a day, and I think I've got 50 or 60 of them. So I will send those through to Satchel 1, on Satchel 1 for all of you to work through. And I will also make a pack of past paper questions, and I'll send them all through to you. And then you can just play around with those and make sure you're happy with that format, okay? I think going through past paper questions is the easiest thing. The only problem is you tend to be, I don't know, maybe you're better people than me, but I tend to look at the answer too quickly. That's the problem that I have with past paper questions. So maybe if I give you a question or a couple of questions and then give you the answer like a week later, maybe you have more ability to not look at the answers than me. But I'll do that for you, okay? So I'll do that tomorrow. Guys, it's 1902. I've overrun, which is a dreadful, terrible thing. Thank you so much for coming. Next week, we've got quite a lot to cover on that, but I hope today was useful. I hope that's kind of helped cement a few ideas for you. And it's just a question of working through it now, making sure you're happy to use it. Okay? Have a great week, guys. I'll see you this time next week. And I'll put this on YouTube as soon as I get it sorted out. Okay? Take care, guys. Bye-bye. Bye-bye. Bye-bye.